Let's talk about Android malware. As most of you know that malwares do not only target PCs, but they also target cell phones, Android, Samsung is part of Android, um, iPhone, whatever. So basically, today we're going to analyze an Android malware. The malware that I selected is very popular. It's called the SpyNote. SpyNote emerged in 2022 and it is still on the market. It's actually being sold in the darknet. You can buy one and send it to whoever you want. So basically, this type of malware is very dangerous because it has been seen impersonating or appearing as banking apps, wallpaper apps, fake Google Play Store apps. Today, we're going to go over this SpyNote malware, analyze the source code, and use, of course, dynamic analysis to see how the malware detonates in an environment. And at the end, we're going to talk about how to secure yourself from mobile malware. Now, here we see real examples spotted in the wild of the SpyNote malware. So this one is impersonating as an Avast antivirus. When you click on download for Android, it's going to download the SpyNote malware. When you click on download for iOS, it's going to redirect you to the iOS store because at the end, the main target for the SpyNote malware is Android devices. And the button here is just to appear legitimate. So that version appeared in, as we said, 2024. Now, previous versions of the SpyNote malware appeared as banking applications. You see here DBS Digibank, and we see the HSBC UK mobile banking. They all look actually very legitimate, very deceiving. Now, you might be asking how the user received or how the users receive these notifications or how they receive these apps. Basically, as you know, all the time it happens through phishing or it happens through SMS phishing as well. We call it smishing. So SMS with phishing, it is called smishing. So users received emails or SMS messages claiming to be coming from their banking providers. Now, the messages claimed that there is an update for the mobile app where the user needs to install the update in order to maintain functionality and security of the app. Once the user showed compliance with the message and downloaded the update or the app, that's what they saw actually. They saw that the app tries to establish accessibility in every aspect. So that's for the HSBC UK mobile banking, and that's for DBS Digibank. Now here you see activate device admin. It asks for admin privileges. Other variations of the same SpyNote malware appeared as, you see here, we saw this one. This is a German bank, and that's, I don't know, whatever this bank, IMTY Bank, Kotak Bank, and of course, there are other banks. And here we see variations that are neither antivirus nor banking apps. We see here Google Play Protect, Play Store, CyberRat. These appear to be legitimate Play Store pages. Once the user downloads, it infects their Android device. Okay, let's now start talking about the spread of the SpyNote malware, how it all started. It started in 2022, where it was the introduction of the SpyNote malware, or the SpyNote Android malware. It emerged as a threat to financial institutions. Now, this means doesn't mean that it attacked financial institutions. It targeted financial institutions by a technique called the impersonation. So by using impersonation, the SpyNote Android malware was able to appear as a banking application to users. Some of the most notable banks that the spyware impersonated are, this is a German bank, and also we have HSBC, and along with a list of banks across the world. The SpyNote malware was able to impersonate these applications and appear to users as a legitimate banking application. It continued the chain of infection by appearing as fake Google Play Store app. So it was spread through fake Google Play Store pages, and it used other apps, maybe as wallpaper apps, messenger apps, myriad of apps. And lastly, in 2024, it was witnessed to be impersonating an antivirus software. It was actually Avast. It impersonated Avast to extend its reach and infect more users. That's the timeline of its appearance and emergence. Now let's have a look at the execution funnel of the SpyNote. So what happens when first the user downloads the app? After downloading and installing the app does another round of installation. Okay, it installs another package. The first step here is APK payload installation. The malware installs a second APK payload using a dialog interface. And we'll see that the dialog interface that the malware uses is just similar to an update interface or a pop-up that asks for extended permission or extended access, as we're going to see in the dynamic analysis. It looks very innocent. Next, after the user grants the permission to do the second round of payload installation, now the app starts asking for the permissions. The permissions, if granted, it allows the app to start harvesting data. In data harvesting, the malware or the SpyNote Android malware tries to collect information such as credit cards, passwords, and as we will see in the reverse engineering, the SpyNote malware tries to get access to crypto wallets, retrieve transactions, private keys, and balances. Next, or the third step, is remote access activation. After collecting the data, the SpyNote malware now tries to access more features, such as the camera and the microphone. Okay, and that's also not good. It's evil. 4, we have the command execution. After collecting the data and have the remote access, now the malware connects to its C2 server. First, it does that by doing a ping command to test the connectivity, and then it sends all the data that it has harvested from the user's device, including the credit cards, information, the password, and wallets data, into the C2 server after testing the connectivity. And it maintains the access on the device using the extended permissions that the user has granted. Okay, so the first thing we want to analyze during Android reverse engineering is the manifest file. The manifest file is the first thing you want to analyze because usually it contains the permissions the app requests. So that's the manifest file of the SpyNote malware, or the SpyNote Android malware. Now we see here there are a lot of permissions requested on behalf of the app. Now the list here is somewhat not that huge, but it contains a lot of permissions, and it is not actually evil on its own to request these kind of permissions, but usually spyware requests these permissions. Let's go over these permissions one by one. The first one here, send SMS. So here the malware requests messaging permissions, enabling it to send and receive basically SMS messages. Now the danger of this permission to be granted is that the app now, or the malware, is able to send SMS on behalf of the user. We see other permissions related to SMS and call processing, such as process outgoing calls, read SMS, read call logs, read contacts, and get accounts. All these permissions allow the spyware to get sensitive information about the user, such as the contacts, the call logs, the messages being sent and received, and so on. Also, we have camera. So this is actually clear that now the app is able to access the camera and take photos. Record audio, the ability to control the microphone. And let's see here, disable keyguard. Now basically disable keyguard here allows the malware to maintain persistence and control over the device. Okay. And look at this one. Receive boot completed, write external storage. Now these allowed the malware to access the storage, and basically that's it. So a lot of permissions requested by the SpyNote malware. So these are the permissions. They are extensive. Actually, a lot of them not usually requested by regular apps, but still having these permissions on the manifest doesn't mean that the app is malicious or malware. It may need actually this extensive list of permissions to perform its function. So that's why we're gonna have to complete the analysis and correlate these permissions with the with other functions and maybe system calls that the malware performs. So we're gonna now move on to analyzing the source code. All right, now you see that many of the classes defined here are defined in Java, and that's actually because the malware is written on Java. At the end, it's Android malware. So now let's start with the very first. I have a public class named brand. You see here this class aims at defining the Android models or brand models that it's going to target. You see there are a lot of models here: HTC, Huawei, Honor, Lenovo, LG, Mobile, and the list goes on. We have also Samsung and Xiaomi, Redmi. So basically all these brands are actually Android brands. So now the app, by defining the class here and the list of the brands, the malware now is able to diverse its target list and infect as many models as possible. Okay, so now let's move on to the other target or the other class. So I have private static here, list supported browser config, get supported browser. So basically here the get supported browser allows, it's a method that lists several web browsers. installed on the device, or maybe installed on the device, such as maybe Chrome. You have the Chrome, Mozilla, Samsung browser, and Brave, Opera, DuckDuckGo, and so on. Now, these indicate that the malware can target these browsers on the cell phone on which it is installed, which means now if at least one of these browsers, if it's installed on the target, the malware can actually manipulate data going through this browser, user data, sensitive data. It can also access the pages, the history, the cache, cookies, and so on. All right, now let's move on to the other class here. Okay, then we have check password method, which uses the accessibility event, and we see here also get view ID resource name. Now these indicate that the SpyNote malware is trying to access keyboard events by recording keystrokes. By recording keystrokes, it's going to be able to track the sensitive information written on the keyboard, such as credit cards and passwords. That's what this check password is for. Okay, next we move on to the other one, public static void send SMS. We saw this earlier when we analyzed the manifest, and we saw that the app requests permissions to process SMS messages. Now here, this is confirmed by using the send SMS method. The malware can now send SMS messages. Next, move on to read all text on screen. And there is the parameter accessibility node info, get text. So possibly here it is reading the all text written on the screen. So if the user was opening some app on their phone and the app contains messages such as maybe WhatsApp Messenger, Facebook Messenger, all of these apps process text on the screen. So using this method, the malware is able to read all text written on the screen, specifically the UI, and maybe send the, it's not clear whether the processed text is sent or stored somewhere on some location, but the existence of this method indicates that the app reads text on the screen. Next we have this, public void on download start, string 2, string 3, 4, 5, download manager request. So probably here it is connecting to some C2 server. We're gonna find out later. If not from the source code, from the dynamic analysis. So it downloads maybe payloads from another C2. Then we have public static void Binance ING. So here we are into crypto. Binance wallet. So here it is enumerating the current wallets. So again, it has crypto currency activity here. It checks the installed wallets on the device. If they are installed, it targets the wallets by stealing private keys and monitoring transactions. Then we have public static void check if get Bitcoin. Okay, and then we have several if statements that check on the Bitcoin wallet and the balance. So it also targets Bitcoin wallets as well. These are the most notable classes defined in the source code. So now we know the main behavior of this malware. So basically, it's a full-fledged malware. Information stealer, connects to C2, monitors user activity. It's a fully-fledged spyware. Next, now we're going to analyze this malware using Any.Run. We're going to do a dynamic analysis and see how it works. Now with Any.Run open, we're going to select a new public analysis or a new analysis, but it's better to sign in. So we go to sign in. Now we sign with your business email and your password. And if you are not signed in, click on sign up, fill in your name, your business email, the password. Make sure that your password meets the criteria, and select sign up. Once you are signed up, you will be able to select new analysis. And from here, since we are analyzing an Android sample, we're going to select Android 14 from the list of the operating systems. Next, we're going to upload the file we want. And lastly, we're going to select the duration, maybe 215, not more. You can make this longer, of course. And lastly, we're going to select run public analysis. Now the Android sample that we have uploaded is being analyzed in a real Android environment, just like when you open it on your phone. Okay, you can click on the horizontal orientation from here so that you see it just like when you open it on your phone. Now we have this pop-up asking us to reinstall. Looks like the app is trying to do another install because something went wrong. We're going to select reinstall. And now it's being installed. Okay, let's have a look. And now we see the icon of the application now shows on the home screen. Let's go back to the installation process. Now, something, I think it's trying to ask for permissions, but it went quickly. I couldn't catch it. Okay, now let's hover over the app and double click the app. Okay. There's a slow response. All right. So now we have this. This is text in Spanish, probably, or Brazilian. And we have this. We're going to click on this button, and now it's asking for the accessibility. Turn on the accessibility. Okay, let's wait. And with accessibility turned on, we can see more things coming here under the DNS requests, the connections. Threats, we have one, but I'm still not convinced this is an actual threat. Let's go back to the app. Let's see what we have. Clear all. And now I'm going to open the app again. Okay, let's see here. So this is the page of the interbank, and I'm just trying to see the functionalities of this app. It looks to me as the official page of the bank, nothing more. If you click on this lock button, maybe this is the sign in button. Nope. And here we have the products, the digital. This green button probably is the sign in. If you click on this, it will take us to another page probably. All right, so probably we're gonna have to compare this to the actual app. So let's go here and type interbank app. Looks like this is the app we're looking for. Okay, now let's go back. Since we have explored the app, we're going to close it again. And now we start the analysis. We can go first to the settings of the app. So here, let's see if we have settings button here. Okay, there's no need for this. Now let's start the analysis. So basically here we have under the processes, we have a lot of processes. Let's go over them one by one. So we have this one, and it is system bin netd. Basically, the netd is a suite of tools on Android operating systems that allows you to use networking utility, ipconfig, IP tables, and so on. So when this is used, it means that the app is trying to do some network activity. So it checks for external activity, and it is a warning. It doesn't mean that there is something evil going on. I'm going to check, click on this, and see what is the IP address. So the IP destination here is 192.168.102. This looks like an internal IP. Okay, we're going to skip this one. There's another IP, the same IP, but different port. All right, this doesn't look dangerous to me. Let's go now to the app process. So we have app process 64, and it is confirmed as malicious. Let's click on more info, and we have two highlights here. The first highlight is categorized as other. It dynamically registers broadcast event listeners, and then we have initiates background APK installation, and that's correct because we saw earlier back there that the app does another round of installation here when it asks for reinstall, and that's completely not normal. So here, this is actually a malicious activity. So probably the app installs first the first payload with the app running, and then after the second round, after the first round, it installs the second payload, right? So the first payload or the original app is like a basic dropper, and then we have the other payload which is installed after the user clicks on reinstall. That's the second payload here, and that's why it triggered this alarm. Initiates a background APK installation. Just click on this, and we can see the function name responsible for doing this second round package installation. It's package installer create session request data. Okay. Now this process, we have another one, ART-D, and here we can see more info about this. The ART-D is part of the ART component or the ART service of Android, which is the runtime service. Now, when you see ART-D or ART-D, It's actually a component of the ART in Android. Okay. Now, what does this do? It actually does tasks that requires elevated system privileges, which usually these privileges are not available to regular users. Now, these privileges allow the file or allow the app to manipulate file system components. Okay. Now, this one should be categorized as warning. That's my opinion. Let's go back now, and now we see a child process to the ART. Let's have a look. So we see this command here. It's a complete full command. Let's have a look. And maybe we can open Notepad. So we have Apex Android ART bin text-to-auth32. This tool is part of the Android Runtime suite of tools. The ART tools allows the processing of the Android application's bytecode. Now, the bytecode of the application is contained within the APK. Okay. After the bytecode is processed with the text-to-auth tool, it is converted into a native format. The format selected here is the auth. And after it is converted to native format, now it can be processed actually faster with the CPU. So that's an optimization process. Going to go back now. Okay, so going to skip these two processes. They look fine. This is the main app process, which we agreed it is malicious because it initiates a second round of installation. Now we see the second round we talked about here. We see it here in a different thread. Let's have a look at this thread here. And we can see we have 24 warnings and 6 dangers. Now first, I would like to take a look at the warnings and analyze them. So we have accesses external device storage files. Now that's not actually normal, because usually Android devices do not request, Android apps usually do not request access to the external storage device. And we have here acquires a wake clock to keep the device awake, launches a new activity, start a service, request access to accessibility settings, and that's what we saw earlier. Probably this one is actually interesting because it allows the app to require elevated privileges, usually system privileges. Collect data about the device environment, retrieve and install applications on device. Just like to have a look at the noteworthy warnings. Okay, we have connects to unusual port and checks for external IP. Now usually, again, these might be justified as the app trying to retrieve updates from its server. So you're gonna have to rule them out by clicking on them, and we can see that this is the IP address that the app connects to, and we have the destination port. I'm gonna copy this for now, and maybe head over to the TI feature. So under the TI, we can run the IP address here, search. Okay, let's go back and see the usual port connects to unusual port. Destination port is 26150. Now, before we give a verdict on the destination port, we can have first to decide what is the verdict for the IP address. So we have 3 total events connected to this IP address, and we can see the date of these events. So this one is 13 April, and this one is 1 April, and this one is 27 March. So this IP showed 3 times in previous analysis sessions, and all the verdicts state, scroll down, these 3 analysis sessions state that the IP is connected to malicious activity based on the 3 analysis sessions that ran before. Other than that, we don't have any clues about the IP other than the country. Okay. And maybe here we have the events. We saw the events, tasks. Okay, let's go now back. So for now, we're going to say that this IP address doesn't look good. All right, now let's go to the dangers. So the first one here is the tactic T1429 uses APIs to record audio and video from various sources. Now the function used here is void Android media recorder. So why would a banking app require you to record audio and video? That's completely not normal. Checks whether the screen is currently on, and that's the function OS Power Manager. So it manipulates the power management settings, probably here to exclude the app from battery optimization, so that when the app is running, the screen keeps the current status, which should be on all the time, as stated by the settings. And then we have determines whether a component is an active device admin. So elevation of privileges, device policy manager, is admin active. So why would an app again asks for elevated privileges? And lastly, we have executes system commands or scripts. Let's have a look at the commands. So function name, Java, language process, runtime exec, the requested data, and that's the command actually. So this command uses the get prop. Okay, get prop is a command in Android that allows the app or whoever runs the command to retrieve system information and system properties. Usually the output is actually key value, comes in key value pairs, and basically this is equivalent of system info on Windows. So here it retrieves the system information. Next we have ping. So it pings this IP address that we saw earlier. Remember the IP address here? We saw that IP address earlier, so it's being pinged by the app with one packet. And then we have another ping with this to the same IP address, I guess. Yes, the same IP address. So now it's actually clear what the app does. So the app starts by retrieving system information, acquiring the necessary permissions, the extensive list of permissions, takes over the complete system by requesting active device admin, retrieve system information, and connects to the C2 server to retrieve further commands, which are not stated here because of it's actually a sample. And now we go back, we see the other processes that were launched, and we saw these basically previously when we analyzed the main parent process. So these are the processes that retrieve system information, connect to the C2 server, and then we have the accessibility menu. The process here is the same process, or its child is the same process, but on a different thread. And this one is the process responsible for requesting the accessibility, and the rest is not important for the analysis. Okay, now the threats here section, we have the same threats we saw earlier when we analyzed the process. Connected to an external IP. Let's have a look. External IP check. Destination is 192.168.102. That's not the one I want. This is the netd process. The process we're interested in is the app process 64. Let's have a look here. And now it connects to possible external IP lookup domain observed. Gather victim network information. So it connects to this IP address. HTTP requests. Let's search with this IP maybe here as well. So only we have one hit. It's Google Cloud Platform. The domain name is ipinfo. So that's the resolution of this IP. It is the ipinfo.io. And if we go back to threads, check again. The TI states that the IP is whitelisted and it is connected to 7 domains. If you go back to threads, we see, now we understand what is this. So basically, it is just analyzing or retrieving the IP information or network information. Okay. DNS requests. Let's go back and search for the IP address in question here. We don't see it here. So there were no observed requests to this IP other than the ping we saw earlier. So only 2 ping commands were observed. And other than that, no DNS request, no connections to this IP whatsoever. Still, we have to find out if there are any noteworthy looking IP addresses. All of these are whitelisted, judging by the check mark or the green check mark. We have a request to this IP. Let's have a look. IP address is not found. Okay. Connections. The IP address of the process is 2446. 2446. You can search here, and we can see all the connections initiated by the process. Now this one, you see this one here connects to the enterbank.dimidex.net. Let's have a look at this domain name. And we see also this one connects to the same domain. Okay. We're not sure about the looks of this domain. Scrolling down, all other connections look fine. And we have this one. We have another domain name. This time it is interbank.ttomtrdc.net. Gonna analyze this as well. Let's see the verdict on this one. The verdict is unknown, but still we have some clue here. Some clues. So these 3 analysis sessions observed 2 suspicious activity and 1 malicious activity. And what about the other one? This is the other one. So now, in total, we have two or maybe three IOCs when it comes to network network activity. We have the IP address we saw earlier in the ping command, and now we have two domain names. That's fine. Okay, let's go back. So now we have two domain names, this one and the previous one we saw earlier. These two domain names were connected to by the app after it is launched. So now we enumerated the process activity and the network connections, and also we found what are the system commands, what are the requested permissions by the app. That's what you need to analyze when you do an Android malware analysis. Now at the end, you can click on text report, and you can also click on IOC to retrieve the list of the IOCs, the hashes, the IP addresses, and the domain names. Still, we have to whitelist a couple of things from here, such as this one, and not all, for me, the IP address that's connected to the app is this one. That's what I would put in the IOC report. Other IPs, you need to analyze them extensively as well. Text report. So the text report, nothing is different from the dynamic analysis, but here, this is a summary of the behavior activities we explained earlier. And if you scroll down, we can see the process tree. So it starts from here, the first one, app process, where it initiates another app APK install, and the main one here, the main process that initiates all the malicious activities. Among them is the ping and the information stealing activities. Process information. Okay, we don't see any notable C2 connection other than the ping we saw earlier that can be considered as malicious. We have this. It is suspicious. 3, 4. Now most of the connections look fine. You can also have a look at the VirusTotal results by checking the hash. We can see that the sample is flagged by 18 security solutions. Let's have a look at them. Bitdefender, Dr. Web, Fortinet, Kaspersky, they were able to flag the sample. The details, we can see the hashes, the submission date, other names of the sample. And let's have a look. Here are the permissions. These are highlighted with red because they are suspicious. Now, read external storage and write external storage, accessibility to the storage on your device, and that's suspicious as well. It all depends on the context of the device, on the app, what it claims to do. A messaging app does not request access maybe to your let's say to your storage, because it doesn't need your storage, like unless it is actually storing its database. It doesn't need this extensive list of permissions to handle the storage. Relations. Here are the shared libraries used by the app and their detections as well. Okay, at the end of this, it's time now to talk about how to protect yourself from cell phone malware. Now, the very first thing you want to do is not install an app from an untrusted source. And install your apps always from the App Store or from the Apple Store. Google Play Store for Android, Apple Store for iPhone. The next thing you want to do is to activate, if you're using Android, activate the option do not install from untrusted sources. Keep this turned off. Keep this turned off. Install from untrusted sources should be turned off. Now, the next thing you want to do is very simple. If you receive a message on your email or on your cell phone claiming to be from your bank, from your telecom provider, and asking you to install, actually attaching a link and asking you to install an update to protect your privacy or protect your account, do not respond to these messages. Make sure to do your application updates right from the app. If your bank or if your telecom provider has released an update to their application, they're going to release this update from within the app. Okay, the app that you installed previously from the official source is going to ask you for an update. There will be no update released by clicking on links or downloading it from any other source. That was it. Stay safe.